Speaker is going to be Paul Miller, who is the Deputy Director and Chief Scientist for NESCOM. And Paul's going to be filling in sort of complete the circle and talk a little bit about the use of biofuels in the sense of power generation.
All right. So I'm going to talk about woody biomass. And Woody from Toy Story has nothing to do with this talk other than sharing the same name. But also an opportunity to give a little public service announcement. My talk's a little different. I'm talking about solid biomass, and really not so much power generation, but the perspective in the Northeast. I should say NESCOM is the Northeast States for Coordinated Air Use Management. We're a multi-state organization made up of 8 state air agencies in the Northeast. So we look at things like woody biomass and its potential in our region in terms of addressing climate planning goals, as well as the potential downside of air quality, if not planned for in an appropriate and thoughtful way looking towards the future. And of course, Woody, while he's a computer animated puppet, I assume he's actually a wood puppet, because that's probably why he's named Woody. Woody's probably painted. And so one of the issues we have with current wood burning devices in our region is people burn things in there that they probably shouldn't burn, like painted woody puppets. And that releases air toxics. And air toxics are a bad thing for air quality. Of course, not only is it bad for air quality, if any kids are looking at you when you burn woody, that probably emotionally traumatizes them for life. But so the PSA is don't burn woody. As far as woody biomass, that's kind of going to be an open question that I would like to go through in this talk. So I want to give you an overview of some of the things we're looking at in our region of the US for incentivizing the use of woody biomass or not. It's an open question. I'm going to give you a sense of some of the dynamics going on. Some of the market considerations we're looking at, and they're very similar to what Dr. Courtwright just presented in terms of costs of wood as a fuel versus other alternatives and the pressures those create. The potential to meet climate mitigation goals in our region. We have state laws in a number of the states that we work with that have set their own state climate greenhouse gas mitigation targets of 80% by 2050. These are enshrined in state law. And so they're looking at measures to achieve that. And when you're looking at 80% reduction, you're looking at everything. One of the earlier slides about EV and coal power plants, that's a nightmare for promoting clean electric vehicles, but plugging them to coal plants. But when you're looking at 80% reduction, you're actually looking at both of them. So you're not, hopefully, stuck with that dilemma. And then I'm actually going to spend a fair amount of time on air quality issues, because that's kind of what our background is in the Northeast. But it underlays these other issues as well. And I'll end up giving the regulatory overview of what we're dealing with on wood combustion, specifically to residential wood stoves and other devices in the Air Quality Clean Air Act context, and some recent changes there. So, reasons to incentivize biomass. Good for climate mitigation, question mark. There are things like life cycle analysis. There's lag time. If you cut down and burn whole trees, how long does it take to replace that tree? It could be zero sum, but if you're looking at a 40 to 60 year lag time for replacing that tree, and you're looking at a 20, 50, 80% reduction goal, you're not going to see the results of that mitigation measure for a while. And so that's something our states think about. Here's what governors think about: local jobs. I would say the biggest driver for looking at biomass in our region has nothing to do with climate, has nothing to do with air quality or anything else. It has to do with job creation. Doesn't matter how many jobs, every job's a good job. That's the governor speaking. So we look at those things as well, and that has to color the context of how we consider this. It does keep money in the local economy. In our region, unlike the rest of the country, on an average, about 25% of residential home heating is fuel oil. That oil is not pumped from our region. It comes from somewhere else. And so that's money going out the region. But we do have wood. So to the extent that it makes sense to convert those residential oil heaters to wood or something else, specifically wood that keeps it in the region, economic development people are interested in that kind of thing. And certainly, if you have the right incentives, I will say the kind of technologies we have in our houses today are really not very sophisticated. But if the incentives are there, we think from experience in Europe, that you can incentivize cleaner burning wood technologies. How clean they can get is an open question, but they can certainly get cleaner. And then utilizing low-value wood, scrap and things like that. So there are, I think, limited resources in the US, and especially in the Northeast, to take advantage of that. And of course, there's energy security, which Dr. Courtwright mentioned that I didn't put on this list, but that is something that comes up. Reasons not to incentivize, bad for climate change. Going back to that climate, the lag time to replace wood, depending on what your wood resource is. Other life cycle impacts, such as transport distances, et cetera, all have to be factored in, as with any energy source. And so that's something we're struggling with, and I think a lot of people are struggling with. Public health is a big issue. It's our central focus. Burning wood does have regional air quality impacts. It also has local hotspot impacts, and I'll give some examples of those later. And then, of course, there's land use change. That's something comes up often. If you're wholesale clearing land for energy use, what does that do to ecosystems, et cetera? Those are issues that come up. Quickly on market considerations, very similar to the previous talk. We were looking at, I can't get this to work. We did an economic analysis of the cost of fuels in our region, looking at fuel oil number 2, which is essentially diesel, that's home residential heating oil, natural gas, cordwood, bulk wood pellets, propane, kerosene, and electricity. We did this back in March of 2014, and then the price dropped on oil and natural gas. So what this table on the right shows is in March of 2014, various prices by volume, and what happened by August 2015. All the fossil fuels dropped. The wood fuels increased, and that changes people's thinking about what kind of fuel choices they're going to make. And that's based on volume, but when you look at the next slide, heat input prices, as well as how efficiently that heat input energy source is used, that tells a similar kind of story. On the left is purely heat input, what you put into your combustion device, various costs going from fuel oil, diesel number 2 on the left, to best-in-class wood devices on the right. I'm looking at the left bar chart at this point in time. In March 2014, just based on pure heat input cost, oil, natural gas over here. Oil certainly, diesel certainly higher than the wood choices on a heat input basis, gas just a little higher. Everything changed in essentially less than 18 months. Oil drops way down, natural gas drops way down, wood goes up a little, and on a heat input basis, it's not looking so rosy for heat in our area, for wood heat. You look at how efficient the wood is being burned versus the other fuels. You have, once again, March 2014, heat oil furnaces, fairly expensive relative to the other fuel choices on heat delivered basis. Wood's down here, conventional wood type devices, advanced type wood devices. Once the price dropped, the oil, fuel oil and natural gas efficiency, dollar per million BTU actually delivered in heat, makes those more economical than wood at this point in time. So how do you take care of the market vagaries as we go forward? And that's a policy decision folks will have to be thinking about. Climate issues. Here's a pure, just based on a CO2 emissions rate, pound per million BTU, putting aside all the things that go into actual production. This is purely out the smokestack. Natural gas on the left amongst the fossil fuels, whoops, wrong button, the lowest, going up diesel number 2 oil, up to coal, Wood, on a pure CO2 per million BTU basis, emits more CO2 than coal. But of course, if it's done sustainably, the argument goes it's a zero emission source. But we don't know how to account for that yet. We had talks this morning on the Clean Power Plan. EPA did punt on how to account for CO2 emissions in state plans that want to use biomass. They basically left it open to the states to come up with options and to tell EPA what they think, and EPA would decide whether that works or not. But beforehand, there's really no clear indication of what may be acceptable. And EPA is going through an ongoing process now to come up with what it deems or help identify what it would deem as qualified biomass under the Clean Power Plan. Amongst our states that we're dealing with, they have something called renewable energy credits. Those are done for electricity purposes, promote renewable energy sources like wind, solar, but also biomass. But there are no environmental attributes to those renewable energy credits. In other words, we don't know what emissions are associated with it. They were done for other reasons. But our states want to use these renewable energy credits because they're investing in them, and they want to use them to get credit for carbon dioxide reductions. How do we do that with biomass? I don't know. We have in our region sort of a Mason-Dixon line that runs along the north border of Massachusetts. Everything north of that is pro-biomass as a climate mitigation strategy because that's actually where most of the trees are. Everything south of that, they're not against, but they're highly skeptical on the use of biomass. So they won't assign any credit to renewable energy credits for CO2 mitigation south of that line roughly, whereas north of that line they want to get 100%. And that's a dynamic we've got going on within our own states. And it's very important because each state has their own climate mitigation law or plan. And if they're accounting for CO2 mitigation reductions differently across states, the public is going to have a lot of problems believing in what they're doing if they're not consistent. And so we have to grapple with that. Air quality. I'm going to spend a little bit more time in depth on air quality. This has been covered before in some of the earlier talks. Wood burning emits a number of so-called criteria pollutants, carbon monoxide, particulate matter, SOx, NOx, et cetera, air toxics. While in our region overall wood burning is relatively small still, its impact on fine particulates is large, and that has significant health impacts. And then there are local hotspots. We don't have enough of a dense enough monitoring network to see everything, but in places like valleys where you get stagnation events, in rural areas where people are more prone to be burning wood, that wood can collect within these valleys and build up high particulate levels fairly rapidly. And then we get the air quality nightmare that we all sit up and lose sleep over. You know, we get pictures like this, which fortunately is not in the United States or anywhere near us. But that is an example of burning wood in a valley on a stagnation day. So we actually have gone out and looked to see what's going on in these areas, in these valleys where we don't have a lot of monitoring. This is a chart from the Adirondacks where we put a monitor for Woodsmoke particulate matter in a car, and we drove it around the roads in the Adirondacks. So the x-axis here is time, that's driving. And then the peaks and valleys are when our particulate matter as we're driving through towns. And so all those names are names of towns in the Adirondacks. And so every time I go through a town, the wood smoke peak spikes. And we're seeing, these are 3-minute averages because we're driving. We're seeing peaks up almost of 65 micrograms per cubic meter. These are very short averages, but they do show that we're getting high spikes in these towns. One of the things we did later, actually this winter, is we went to Saranac Lake, which is in one of these towns right here in the Adirondacks. We put a stationary monitor in a neighborhood. We picked up a 3-hour average of, I think it was 300 micrograms per cubic, well actually it was 1 hour average of 300 micrograms per cubic meter, no, 1 hour average of 400 micrograms per cubic meter, 3-hour average of 150 micrograms per cubic meter, and a 24-hour average of 64 micrograms per cubic meter. This is not a regulatory monitor, so we're not going to see a violation, but that's what we saw. The health-based standard, 24 hours in the United States, is 35 micrograms per cubic meter. And this wood spike that we saw in this neighborhood, we think is entirely attributable to a single wood stove in a neighbor's house at some distance from where the monitor was, not in the same house. So those are the kind of issues we're going to have to grapple with if we don't improve things. So the regulatory overview, and this is where we're trying to improve things on a national level as best we can. There is a new NSPS, so-called New Source Performance Standard, that are going to influence residential wood combustion in the future, but it only addresses new units. We have a lot of old existing units out there that are going to continue emitting for a while, and these can be refurbished and resold without limit. There are advanced wood-burning units available, especially in Europe, but even these units are higher emitters than the fossil fuel sources that they might replace. So over on the left is phase 1 of the New Source Performance Standard. The phases in first, comes in a little later, step 2. This is the emission rate for PM 2. Actually, not an emission rate. It's essentially an estimate of pounds per PM emitted per day by the device if it met that standard. This is a pellet wood-burning device with so-called thermal storage. It's a way to downsize the device to improve its efficiency. That lowers its PM emissions. That's an advanced technology developed in Europe. But compared to oil and natural gas current boilers that they might replace, you're going to take a whack on air quality if those are the kind of devices that are going to go out there. And so that's something we've got to deal with. Another example is industrial, commercial, institutional units. These are larger units. There are no federal limits that apply to these, so it's left to the states. Our own states don't do, I think, a really consistent job of dealing with these kind of units. These are 10 million BTU heat input or less down to 1. These are a number of states in the New England and Northeast region. New York, by law, has 0.06 pounds per million BTU emission rate. Vermont does it on a case-by-case basis, and their most recent determination is 0.03. Huge discrepancy on a state-by-state basis of how these are handled. And then finally, and this is not a Volkswagen issue, but it's kind of similar, is testing. The tests for these devices are really difficult to do because wood is not really a consistent kind of fuel, and how it's used in terms of cycling is really difficult to grapple with in the laboratory as compared to the real world. So the tests that we've looked at come up with pretty large differences in what the emissions might be. We can't say which is better. So these are just same unit type, but two different types of test methods. One gives 0.06 pounds per million BTU, and the other one gives 3 times higher. And the efficiencies that they come up with are a little different. And finally, this is a standard test that's actually used now. This is not cheating, but the way we test now, and it's for consistency, is the test method is to use so-called crib wood. This is dimensional lumber, like 2x4, stacked in a very specific way inside the wood-burning device. I don't know anybody who burns wood like this. I don't have a wood-burning device, but if I did, I wouldn't go to Home Depot, I wouldn't buy 2x4s, and I wouldn't stack it like this. But this is how we test. And we test like this for consistency, but not for real-world use. And so we're looking at ways now to figure out how to come up with better tests. So this isn't like Volkswagen, because this isn't cheating. This is the way it's done, and you still don't get the right answer. So in summary, what's next for wood burning? Lots of stuff going on. I can't say what the future holds. It has its pros and cons, just like with every other energy source out there. We're still trying to get a handle on the air pollution challenges we're facing. There's a lot of pressure for economic development, and that's a good pressure, but we got to do it in a way that doesn't sicken a large part of the population. Devices can be cleaner and more efficient, but what we're finding is that The biggest barrier to wood burning right now may not be regulators, it may be your neighbors, because those are the ones who complain the loudest. The homes are the biggest investments most people have, and if somebody puts in a high-emitting source next door, not only is it bad for your health, it probably destroys your resale value. So that's where we get the biggest complaints from, for anything we do. And so that, I think, is going to be a huge market obstacle for the future use in this particular context of residential wood use that the industry has to overcome to really, assuming everything else works out, to really get this market off the ground. Thank you.